Atomic mass, it's the mass of an element. Again, atomic mass, mass of an element, but in relation to some other elements. Our element of reference, or the element of choice we always use in chemistry as our reference, the one we compare other elements to, is always carbon. Why we choose carbon to be our relative element or the element of choice? Because carbon is like found everywhere, right? You find it in graphite, diamond, charcoal, in your body, right? Carbon is like one of the most abundant or most available element in the world. So for that reason, when I am weighing atoms, I compare them to units of carbon. So for instance, one carbon, how much is the mass of individual carbon? One carbon is, the mass of it is 12, okay? So how many hydrogens would be equivalent to a single carbon? It would be like 12 hydrogens, right? So 12 hydrogens are equivalent to a single carbon, all right? For instance, someone asked me like, how much is the mass of one magnesium? Magnesium in the periodic table is like 24, right? So how do we compare this to a carbon? You tell me, well, every magnesium is worth what? Every magnesium is worth 2 carbons, okay? So that's what relative here stands for. It stands for the fact that we're going to relate the mass of the element to carbon. And that's why they write it here. Look what they write. They write always in the actual IGCSE periodic table, they write relative. Again, when they say relative, this means we're relating them to the element carbon. Okay. Now, what unit we're using here? Because we say 12, sometimes we say 24. These are units of what? These like grams, kilograms, tons. Actually, they're very, very small units, really small units. Usually, they're very small in a way that it's the mass of it, it's like almost negligible, really, really small. And again, when I say, for instance, atomic mass unit, which is the mass of an element, again, the unit we're going to use here is called atomic mass unit. Again, it's really small in a way that it's way, way smaller than a gram, right? It could be like 1/1,000,000,000 of a gram. But how do you understand it? How do you think of it? How would you imagine it? Think of carbon again. How much was the mass of a carbon? The mass of a carbon was 12, isn't it? And that's our reference element. So if I say atomic mass unit, what does that mean? This means it's one of those 12 units of carbon. So again, think of carbon as a jar, and you have 12 atomic mass units in it. So when I say atomic mass unit, it means one of those 12 particles, protons or neutrons, you have in a carbon. So for instance, someone tell me, what's the mass of a hydrogen? The mass of a hydrogen in the periodic table is 1. 1 what? Tell me 1 atomic mass unit. And how much, what's an atomic mass unit? It's one of those 12 units or 12 particles you have in a carbon. So let's just sum up what we said. We said carbon is your reference element. It has a mass of 12. It's standard unit. It's the one we compare all other elements to it. Okay? And an atomic mass unit is what? An atomic mass unit is one of those 12 particles or 12 units that you have in a carbon. Did you notice that I wrote carbon-12 here? Why am I writing this particular? Because I'm only interested in this isotope of carbon. So that's the most available isotope of carbon. And that's one we use all the time. So that's why I wrote carbon-12. So that's the actual carbon. Because you have carbon-13, you may have carbon-11, you have many isotopes of carbon, but that's the one that we use all the time as our reference element.